Yeah.
Okay. Cool. Where's the? Here it is. Okay. Hello guys. I'm gonna get started now. I think it's 8:35. How was your spring breaks? Good. Yay. Glad to have you guys back. Hopefully you guys watched the eclipse today or not, since there was a lot of clouds. But hey,
We attempted to.
Yeah, I don't know. I made the trip, but I literally looked at clouds. So, a little sad, but that's okay. Okay, quickly, A3 midpoint is due tomorrow night. So, just to reiterate, the midpoint we only care about if you make like one commit. So, you can technically put as much effort as you want into that midpoint. And the important part is that the final graded submission is due next Tuesday. So, that's the part where we actually will run your app and make sure that it works and has all the functionality. Any questions on this? No? Okay. Yeah, we'll just all you have to do is submit your repository link on CMS, and we'll just click open it and just check you have something committed or started on it to some extent. Okay, cool. I know it's been a long time. I feel like it's been forever since I've set up here. But just for a really quick recap of last week, since we'll be kind of diving into networking this week, so it's very different-ish topics, but a recap for last week's lecture, which is working with collection views. We had an init function, and we saw how that differed between a collection view and a table view. And then for a collection view, we also had to go through setting up a flow layout. I know Richie went through that whole process of going through all that code, and you can also take a look in the demo of last week. And then we also had to conform to this delegate because we had to set the size for each item because, the collection view, if you recall, it's kind of like the Photos app, right? You have a bunch of rows and also a bunch of columns, so it needs to know how big each item should be. And then also we use items instead of rows because now it's not just rows anymore. Now we also have different items indexing from 0, 1, 2, 3, 4, 5, and 6, and so on. So this week we're going to cover networking. I think Richie's going to get started with HTTP requests.
Yep, sounds good. So we are at sort of that halfway point in the course where we're sort of going to shift gears away from just solely integrating and, sort of implementing the UI of an application. So normally, what we've gone over so far is how we can design and as well as implement UI, features of the user interface, which includes labels, text, things like that, as well as, some of the more complex ones like the UI table view as well as the collection view. But today we're sort of going to shift gears a little bit and, go into sort of how we can fetch data from a backend API. Sort of shift gears into the second half of the course where we're going to teach you guys how to sort of integrate your front-end code with the backend code that you'll eventually be using for both A3 as well as, later on with the hack challenge when we're doing the final project. Okay, so the first thing we're going to go over is what HTTP requests are. So HTTP requests sort of, actually before we jump into that, so HTTP requests are sort of a way we can communicate with the backend. So, so far what we've done is that we've used a lot of hard-coded data. So even with the table view as well as the collection view, we've used hard-coded data in the form of, as we call it, dummy data. So if you started on A3, you might have noticed that, sort of the struct or the data that we're using are posts. And those posts sort of, for at least the midpoint section, we're using dummy data to sort of display that data. However, later on when you submit that final part of the assignment, you're going to actually requesting the posts from a backend API. So this is sort of where, networking as well as HTTP requests will come in handy. Okay, so before we jump into, how the structure and how HTTP requests works, so we're going to go over what sort of this is based off of. This is based off of the client and server model. So if you don't know, a client is a device or software that requests a service, and a server is a device or software that responds to the clients with these services. So again, to reiterate, client send a request, and the server responds to that request. So in the sort of context of the course that we have, our clients that we've created so far would be our iOS apps on our devices that we have. So, like A2, things like that, those would be our clients where we want to display the data, but the server is sort of whatever device or software that we want to take the data from. So supposedly, we're not always going to have the same data every single time. So if you're using an app like Instagram or messaging or iMessage, things like that, things are constantly being updated. People are sending messages constantly. You're not always going to have the same data at every single point in time. So this is where sort of we use a server to allow us to communicate from the client and the server so we can retrieve information from that server. So in this case, your iOS app is the client and the server will be some sort of backend that, either you or, your partner implements in the hack challenge. Okay, so again, this is just sort of, another visualization of it. So there are different, types of clients, your laptop, desktop computer, as well as iPhone, things like that. Those devices can be clients as well as the software that on those devices. Those can also be clients as well. And server you can just think of as one big computer that you can sort of store data as well as request and post data to. And sort of how all of that is connected is through the internet. So you're going to be using internet to communicate between your clients and your server. Okay, so just a quick overview of what an HTTP request is. HTTP, I believe, translates to Hypertext Transfer Protocol, which is a method used to communicate between a client and a server. So this is just one way that we can communicate between a client and a server. There are many other different ways, but just for the scope of this course, we're only going to be using HTTP. So some of the common requests that you'll see are going to be get, post, put, and delete. However, just for today, we're going to discuss the get and the post requests, which should be pretty self-explanatory on what they do just based on their names. So what a client does is we send a request to the server, and the server responds back with a status code or a message, which ranges from around 100 to 500, sort of indicating what, how the response has been received. So it can either be good or it can be bad. So as a general sort of oversimplification, 200s are good, 400s and 500s are usually bad because they indicate, an error has gone wrong with your request. So here, are some examples of HTTP errors that you may get in response to sort of sending any request. So let's say you send a request, anything that is 100 or followed by any within that range, 100 would be informational, meaning the process is still undergoing, and it'll sort of give you updates on, what is currently happening. 200 is what you want. It means that, your request was successful, and either it'll return, whatever success message or whatever you're requesting as well. So if that's a get request, you would get a sort of that array of things that you're getting or, any other thing that you're fetching from the backend. So 300 is not really going to be really covered at all. We're not really going to encounter the 300. It's sort of when you're rerouting anything, but in this course, we're not really going to have any situation where that's going to happen. So you can just ignore that one for now. And 400 and 500 are the ones that you don't want to see. So 400 usually means that you've done something wrong. So that means you've inputted the request wrong, or the request or URL are incorrect. So if you know a common one that is error 404, which is not found, but there are many different versions of this, but any error that starts with a 4 means that it is a client error, means that you inputted something wrong or something in the translation process of sending information from the client to the server went wrong on the client side. So if it was a 500 error, it means that there is a server error. Most likely, it is not your fault, but there are some instances where this could be your fault. Most of the time, when there's a 500 error, you kind of just blame it on the back end, so that's out of your hands now. But there are some occasions where you do have to watch out for 500 errors. But generally, 400 means you did something wrong, 500 means the back end did something wrong. Okay. So now we went over HTTP, we're going to go over sort of the language that is shared between the client and the server. So this is the sort of language that allows us to communicate between, a front-end client and a back-end server. So, in our course, we're sort of coding our front-end client in Swift, and in the back-end course, it's using an entirely different language as Python. So this is sort of how we are able to communicate between the client and the server, despite both programs being written in different languages. So this is where JSON comes in, which stands for JavaScript Object Notation. And it is a text-based data format that is language independent. Like before, it means that you can use this regardless of whatever language your software is in. So like, dictionaries in Swift, JSONs have key value pairs, both of which are strings. So the keys are always strings, or actually not, just the keys are always strings, but the values can be anything ranging from numbers, arrays, objects, booleans, or any sort of type that you have there. And here is sort of like an example of what one would look like. So on the left here, we sort of have something you may be familiar with is, a Swift struct. So a model of sorts, we have the student model. I think we covered this in a previous lecture before as well. But this is sort of, how you would define a struct, as well as call the constructor to create such an object. And this is what it sort of would have looked like in the sort of JSON notation. So this is the language that you're converting to in order to send this information that you're storing on the front end. and send that information to the backend. So essentially the process goes, you're converting that Swift struct to a JSON, and then that JSON is sent to the server or the backend, and that's sort of where they are able to process the data while sort of still understanding what you're doing because they have this shared language of JSON. Okay, so Tiffany is sort of going to cover a demo of how we're going to make a request, and that's going to be using Postman, so Tiffany's going to cover that.
Cool. Okay, so who's heard of Postman before or have used it before? Okay, cool. But if you haven't, it's a pretty simple software, I'd say. I mainly have used it to like debug network requests or see like example ones. So if you head over to our course website and you go down to the networking lecture, there is a link here that takes you directly to installing Postman. I believe if you don't want to install it, you can use a web version of it. So if you just wait for this to open, I think you can log in like here and you're able to use a web version of it. But essentially, let me go back to where this is. So this is the endpoint that we're going to use for today's lecture. So this is going to be acting as a server. So we're going to be making requests to this, and Postman is going to act like the client. So if you remember from what Richie said, the client requests something from the server, and the server responds. Right, so in this case, let me open Richie's Postman real quick. So if you can see here, I'll make this bigger. Perfect. So once you have Postman open, you can create a new request by just like adding. You might have to create a new collection first, but after you create that, you can create a new request simply by clicking new. You want an HTTP request, and then this is where you want to enter the endpoint that you want to request information from. And in our case, it's simply going to just be this endpoint that it's already set up. So we put this endpoint in, and note that there's a kind of a drop-down menu here. So this basically is all the different types of methods that we can use on this endpoint. So the get method, I guess is a get request, right? So if you see we hit get and we hit send, we get back a bunch of information from this endpoint. And in this case, it's just a bunch of I guess the subteam leads of app dev currently, as you can see. So this is a get request. But if we change this to a post request, did we go through post requests and get requests?
It's just like the overview of them. It's like.
Oh, okay. So if we put a post request, that's basically we're trying to indicate that we want to like send some sort of information, right? And in our case, if we want to send a new, I guess, like person into this whole backend server that has this like that database with all these different people, if we just try to hit send like this, you'll notice that it gives us an invalid request body as the error. See? It's a 400 bad request, which means it's a client error, which is correct in this case because I am the client, like I am Postman IE in this case, and it's failing on me because I'm not giving it the correct body. And what that means is that if I want to create you can imagine if I want to create like a new Instagram post, you have to pass in some image, some title for your name, for your post, some caption for your post, right? If you just try to make a post with nothing, like Instagram is not going to allow you to do that. So in our case, we also want to be passing in some sort of body. So if you head over to this like body tab right here, and you click, I believe it's raw, and just make that a little bigger, and you want this to be in a JSON format, so you might have to switch that. And we're going to type in some JSON in order to create a new field. So if you saw from earlier, I guess not. In this case, we're going to have a name field. So let's use Richie's son in this case. And then this is kind of similar to Swift dictionary notation, but it's slightly different because in this case, it's string to string. And then we're also going to have a position. So I'm going to put course instructor here. And then we also have a subteam, and that's going to be iOS. So once we have this body filled, if you click send now, notice that we get this, basically this JSON object back. But now if let's save this and save it to this. So now we have this post request, right, saved here. Now if I try to get all the posts, call the get request on this server again, notice that I guess we tested it on this earlier.
Wait.
No, I think everyone also, did you guys also made the. No, it's good. Wait, it's good. Wait, you guys.
Wait, that means it works. So
Yeah,
you guys,
that's good.
that's great.
Oh, that's a lot of Richie sons.
Yeah, so keep in mind the server is shared among everyone. So if
Yeah.
someone posts information, you get it. Everyone will be able to see it. So yeah, that's good that sort of everything is showing up.
That's good. Okay, that's perfect. Actually, that's a good example. So we all use the same endpoint, which means we all hit the same server. So it kind of makes sense why when you guys all sent your post requests and I hit this get request, I get all these back because you guys also sent, I guess like 5 of you guys or 4 of you guys, excluding me, also made the same request. So now it appears here. So like for example, if I switch this to, really quickly, Tiffany Pan, just to show that this works, if I run the get request again, you'll see that it does indeed have my newest request. Any questions or anyone running into issues with Postman? Usually some issues with Postman is just like make sure that this is the correct format. Like double check there's no syntax errors. So this should be a colon. This key has to be a string, but in our case, our values are also strings. And make sure there's commas after this. No questions? Okay, so I'm gonna move on to talking a little bit about something else very important for network requests. So, if you've ever used Instagram and let's say you're in an area with really, really bad Wi-Fi and you try to open your feed and you get that like gray screen, I believe, and you're just like, what the heck? Like my Wi-Fi sucks and nothing's loading. But notice that when you get that gray screen on the most recent post, you're still able to like kind of scroll around, right? Your app doesn't just freeze and crash just because your Wi-Fi is slow, right? So that's kind of the importance of callbacks. We don't want our apps to just freeze as we're waiting for a network request. Okay, let's move on. Okay, so for Instagram, a lot of the information that we fetch is from their servers, right? There's no way we're gonna be able to store all those reels and all those images locally on our computer. So every time we want to fetch posts for like our own feed, we're basically making a whole network request to their servers. Does that make sense? So when you like post a new photo or you load a new reel to watch, the app is basically asynchronously, in other words, running in the background to make that request. And what that means for us is that we want it to run in the background because if you imagine every time like you're waiting for a request to finish and your app freezes up, that's like not very user intuitive, right? You don't want the app to just like freeze while you're waiting for something to load. Like for example, if you were loading like a big, I don't know, like song library and your Spotify freezes, it'd kind of be bad like for the user experience. And this is why I think the next part, that's why we use callbacks. And it's gonna seem a little vague right now, but it'll make more sense, I think, once I give a more, anecdotal approach. So more technically, a callback is a function that's passed into another function as an argument. So let's call this another function, like the original function, and let's call it callback, like the callback, right? And this callback function is called after this original function completes. So you can imagine, that, so if we were talking in the case of Instagram, if we were trying to fetch someone's feed, for example, we would try to fetch the feed, but note that you won't be able to get that response immediately, right? Because it has to go to its servers, it has to get all the information, it has to process it, get it back, decode it, and then we can finally display it to the user. But by that time, the user, like everyone has like short-term attention span, right? You already want to be clicking on something else, but by that time, the user, like you still want the user to be able to use the app. And what the callback does is that when we finish fetching all this data, we call this callback function, or also known as completion handlers. So we call this completion handler to tell the app that, okay, this is the request you asked for, this is all the posts that you fetched, and when this completion handler runs, it updates the user's UI finally with all these new posts. It's a little, convoluted, but I think a good anecdotal is literally the phone callback option. So if you ever called like a really busy line, like, I don't know, like the water department or something, you'll notice that when you dial a number, they'll usually be like, oh, if you want a callback, like leave your number and whatever, and they'll be like, a rep will call you back, usually whenever they're not busy anymore. So you can imagine like the original function in this case is like calling the water company, right? That's what you originally intended to do. You wanted to call the water company. So you dial a number in your function, you dial a number, you click the correct numbers, whatever, you go through like click 9, whatever, for a water leak or something. And during this time that they ask you if you want a callback, and you say yes, like, okay, I want a callback, you can do something else while you're waiting for this company to call you back. Does that make sense? Like, I guess like analogously, that means that like you can do something else on your app while you're waiting for this network call to finish. That was kind of a mouthful. Is there any questions on that? So the important part is that like while we're waiting for this original function to finish, and this function might take a long time, like fetching all these posts or waiting for, I don't know, water company to finish wrapping up everyone ahead of you, we're able to continue using the app. And that's important because we don't want the app to just freeze. Okay. So you can imagine this is kind of what a callback will look like in Swift. So you have this function. So this is the original function I was talking about earlier called fetch feed. And the callback is this completion handler here. So the completion is the name of the function. And this is being passed in as an argument, as mentioned here. And we have this at-escaping notation. And inside this, I'll go through at-escaping in a second. But inside this function, you'll see that we have a bunch of, we I guess initialize this post variable. And we make a backend request to get all these posts. So in that case, that would be like this Postman. Oh, I don't have any more. But it'd be making this Postman request, right? So essentially what's happening in this here, like send a request, you're basically making this get request here, except on Swift, which we will show you guys next week. But you can imagine if there's like a bunch of information here, like the amount of time it would take to get a response back would be much greater. And you don't want the user to be waiting through that, right? So you go through this, you go through that, and then what happens is that when you finally get all your posts back, you call this completion handler, and that's what's happening here. So this is a function, and we're passing in all the posts that we just got back. So a post finally gets updated somewhere in the middle here with all the new posts that we just fetched, and we call this completion handler with this post variable. And typically, this function will be defined as like it will update some sort of like table view that shows your posts. Okay, and I guess to briefly cover what at-escaping does, it just means that usually the closure, so the closure in this case is also called like the callback, will outlive the scope of the function. This means that this will, I guess, last longer than this original function will be alive for. Does that kind of make sense? I think it makes more sense in the scope of like an actual network request. So we'll go through that like in the next lecture where we actually use all these terminologies and like use that to actually get something from a backend endpoint. Okay. No questions? That's kind of a mouthful. Okay, cool. So I think Richie's gonna go over codables.
Yep. So as Stephanie demonstrated with Postman, like right here. So when you sort of send a request, you can notice that either the backend gives you sort of the data that you want. So in this case, when we perform the GET request, we get the array of members or subteam leads. And, either that or, if we type something wrong or we get the body incorrect, we get an error. So in the case that we sort of actually do get this information, how can we actually process this into Swift code? How can we convert from sort of JSON back into Swift notation? So this is sort of where Codable comes in. So, as you can see, we have a JSON that we get from the backend, and we want to be able to use that now within our Swift code. So there are two sort of protocols that are, integrated in Swift that help us do this, and that would be decodable and encodable. And they are sort of combined, just decodable. So whenever you're implementing this, the protocol you would just use would be Codable, because Codable encompasses both decodable and encodable. So yeah, that's sort of explained there. So Codable, you could just think of, the protocol that sort of implements both decodable and encodable. So that allows you to sort of encode into JSON and decode from JSON. So this is sort of the protocol that allows us to communicate with the backend server, because we're able to convert structs into JSON and vice versa. So within the scope of the course, we're not really going to creating any custom coding keys or custom encoders or decoders. Swift has its own built-in decoder for JSON, so we'll be mainly using that. So you don't really have to worry about creating your own custom coding keys or encoding or decoding from JSON from scratch. That's sort of something that Swift will handle for you using the JSON decoder. Okay, so here's sort of an example of how you would make something codable. So we had these previous struct before, the student, and you can see that now we are implementing it as a codable struct. So codable is, as you know, a protocol. So we implement a protocol by specifying it after the struct or class name and behind the colon right here. So this sort of allows us to indicate that this can be encoded into JSON as well as decoded from JSON. So this allows us to sort of convert information like this that we get from the backend, which is in the JSON format, and allows us to sort of automatically decode that JSON into sort of a structure that Swift better understands, that being the struct or the class. So note that the differences in naming conventions. This will be important later on when we go over actually network requests in the next lecture. But you can see that these are sort of the same structs, but you can see that one is in sort of this underscore case called snake case, and the other is sort of what you're more used to with camel case. So this is sort of the convention that we'll be using. So the backend mainly uses snake case, and in any struct that you're using, you'll be using camel case. So in this Swift decoder, there's actually a way you can convert from snake case to camel case, so you actually don't have to write your own string processing function to do that for you. So we'll also cover that in tomorrow's lecture. But for now, you can just sort of I guess recognize that there are two different sort of standards that we're using. One where JSON is in snake case, and one in Swift where we're using camel case. But yeah. So this is the Codable model, and this is the JSON that we're using from the backend. Okay, I think that's it, but I think we still have quite a bit of time. So I guess I can explain a little bit more of what we can use Postman as a tool. So this is actually not what we'll be using the majority of the time to implement the actual backend of your applications. This isn't really connected to any Xcode project or things like that. This is sort of a way you can debug a lot of your code by sending a request through Postman directly, rather than using the application itself. So in the next lecture, we'll actually cover more on how you can implement this sort of networking within your code itself. But today's lecture was sort of just to demonstrate how networking works, as well as just sort of some, conceptual, system based concepts on how, we can communicate between a client and a server. So you can see this URL here. We didn't really do anything with that. We sort of just copied and pasted it, but there's a lot more coding that goes in, that's more involved in that. And that is sort of more on the backend side of things, so I won't go into too much detail there. But this is sort of the URL that stores our connection to the server, and using internet we're sort of communicating between our client and server through our sort of communication hub, which is in this case the Postman. So the Postman is acting as our client in this case, because it's making the request to the server, which is the backend, at this URL. So yeah, this is sort of what we're doing just for this lecture only, but later on, when you'll see with the next lecture on Wednesday, we'll sort of teach you guys how you can integrate this within your Swift code, so you don't have to sort of switch between two applications just to test it. But Postman, it will always be a useful tool for you guys to sort of test your backend calls, or even just understand the structure of how they work so that you can actually implement them in your Swift code. Okay, any questions? Okay, perfect. Start with the Kahoot. The audio working.
Oh, okay.
It's the music. This is really.
I swear I heard something. Wait, click it again. No, I think I'm normal. You look at your sound settings. Never mind. I think it's your. I don't know where it's called.
I thought it was right here, but I think it is connected, but I don't know why it's not working.
It's connected? Oh, yeah. There you go. Question mark.
Weird.
Oh, that's mute.
Oh well,
Sad.
I guess just
Awkward.
we'll just do it without the music. All right, is everyone in? Okay,
Oh.
you guys just imagine the music, I guess.
You can sing for the Richie.
I'm not singing.
Oh wait, what?
What?
There's sound.
Wait, the sound. There's no music.
Oh, maybe we
Anyways,
turned it off.
when is the final submission due for A3? Oh,
Is it lagging? Oh.
this is buffering.
There's a metronome.
Like,
Oh my god. Should we disconnect it?
yeah, this is
I'm kinda
just-
scared.
This is mute. We're gonna get jump scared. Okay, yeah. So the final submission is due next week. Keep in mind the midpoint, however, is due tomorrow. So make sure you actually have something on your GitHub so we can actually give you credit for that. That will be for completion. So as long as you put in some effort in completing the assignment, we will give you full credit for that. So make sure you submit that by tomorrow. All right, nice. Nice. Okay, what's the relationship between the client and the server?
Oh no, why is it so small? Damn. I don't know why.
That's it, right? That's good. Yep.
Oh,
Oh,
nice.
damn, everyone, 100%. Yep. So the client is the sort of software or device that requests, and the server is the software or device that responds to that request.
So Postman in our case today was the client because it was the one making the requests. Okay. Cool. Next.
Okay, a 200 response indicates success.
It's 11 people, right? Oh.
Yeah.
Oh. Someone spammed it wrong. Yep, so 200 is success, 400 and 500 are both errors. 400 is a client error, which means usually you did something wrong because usually you're the client making the request. And usually a 500 is a server error, which means either the backend is down, the server's not up, or some sort of issue that's usually out of your hands. So, yep. So true or false, JSON is language independent. Wow, we were so fast. Is it 12 people? It's 12
Oh, it's
people.
my bad.
Oh wait, is someone like purposely inting? That's so funny. Yep. So JSON is language independent. So you'll notice that we use, if you've taken any other CS classes, JSON is sometimes used across a lot of different languages to kind of represent data and structures. Okay, I think the last question. Oh wow, I really like true or false today. So true or false, we should synchronously execute network calls. So synchronously means like, I guess like you wait there, like I guess like synchronous class. Yep. So it is indeed false. You should asynchronously execute network calls. So what happens if you try to synchronously execute is that if a call takes a long time, you'll essentially be waiting for that call to finish before your app can continue functioning, and you don't really want that for your users. Yep. That's it.
Yep.
Nice.
They fixed the glitch.
It's so anticlimactic without the music. Oh, maybe? Oh, never mind.
No, they did not fix it.
Is it a Safari issue, maybe? I don't know.
Maybe it is.
Yay! Congrats. Okay. I think we don't have any announcements?
It's like the...
It's just the...
Yeah.
Okay.
Yeah. Okay.
Wait, what?
Safari glitch.
Oh, sorry.
Rip. Okay, well...
Yeah, no announcements except A3 is due tomorrow night. We'll be here if you guys need any help with up to the midpoint or past the midpoint if you've gone to that. And yeah. Thanks for coming.
Yep.
What happened to Safari's now? It's like glitched.